A polynomial, this is my definition, not a book definition, is a term or a sequence of terms of different powers of x, or whatever variable that you have, linked with plus or minus signs. I'll say that one more time since I'm not going to write it down. A polynomial is a sequence of terms that are linked with plus or minus signs, right? Adding and subtracting, with varying powers of x, or whatever variable you're dealing with. Usually we talk about x, so I'll talk about powers of x, but you could have a polynomial with y, if that's your variable, or a or b or whatever, but typically we'll talk about x. So the easiest way to discuss it is to give you a couple of examples. So let's start with the very simplest thing we can think of. Let's talk about x squared. Let's see if it fits the definition. It's a multiple terms linked with a plus or minus with various powers of x. Now you might say, well, there's not multiple terms here. There's no other terms there. Well, yes and no. There are no obvious other terms there. However, if you think about it, I could have a plus 0 out here and you'd never see it. 0 is a number just like any other number. So I could have an invisible plus 0 there, so really it is kind of multiple terms linked together with a plus sign. But that's kind of a silly way to define things. I mean, ultimately, you can think of polynomials as being any number of terms linked together with plus or minus, 3 terms, 2 terms. Even if it's only one term, we still call it a polynomial. Well, we call it a monomial. I'll write that down in a second and explain why. But in general, the class of things we're discussing is called a polynomial. So x squared, that is a polynomial, even though there's only one term. Another one might be 3 times x to the 4th power. Now, yes, there's only one term here, unless you consider plus 0 as another term there. We still consider it a polynomial. What about negative 2 times x to the 5th power? We obviously can't combine the 2 with the 5 or the 3 with the 4 or anything like that, because this 2 is sitting out in front, or this negative 2 is sitting out in front multiplied by x to the 5th. This 3 is out in front multiplied by x to the 4th, and in front of here is actually invisible 1 multiplied by x to the power of 2. Now, even though this section is called polynomials, it's a little bit silly. You know, the word poly means multiple nomials, right? But these only have one term. So we actually have a special name for these guys. And if you think hard, you probably could even come up with it. It's called a monomial. So the general idea is polynomial, meaning many, many terms. But there's only one term here. So mono means one. And so we have one term. This whole thing is a term. This whole thing is a term. This whole thing is a term. So notice that you have a negative 2x to the 5th. You might think there's multiple terms. The terms in a polynomial are the things that are linked by plus or minus signs. And so the whole thing is grouped together as a term. All right. Now, one thing I want to point out before I go on too far here is I want to talk briefly about the degree. So these are very, very simple polynomials that we call monomials, right? The degree is basically going to be, the degree of a term of a polynomial is going to be the highest power that term has. So when you see something about the degree of something, it generally means the highest power of x, or whatever it is you're dealing with. So this guy here, because there's only one term in x and it's got a power of 2, the degree of this guy, I'll put DEG, but it stands for degree, is equal to 2 for this term, right? The degree for this term right here, what do you think it is? 3x to the 4th power. It's the highest power of x, but there's only one power here. So the degree for this term is equal to 4 right here. And the degree of this term right here, degree, is equal to 5. So when you see something about what is the degree of this term of a polynomial, all you have to do is say, well, what's the highest power? That's a 2, so that's a degree of 2. Here's a 4 is a power, so the degree is 4, degree is 5. Very simple stuff so far. All right. Now let's continue on down the road. This was a polynomial that we call a monomial because there's only one term. Now let's look at a slightly more complicated type of polynomial with 2 terms. So it could be anything linked by a plus sign. So here's x plus 2. Notice that here's x with a power, the invisible power of 1, linked with a plus or minus to another term. In this case, there's no x present at all. It's just a 2, right? Let's take a look at another polynomial with 2 terms. X squared plus x, there's 2 terms here. Let's take a look at another one. Negative x to the 3rd plus 3x. So notice I'm picking and doing things in sequence here. These are all polynomials with 1 term. These were called monomials. These are polynomials with 2 terms linked by a plus or a minus sign, right? Now, because these guys, these are also called polynomials, but because there's only 2 terms involved, we have a special name. What do you think? Here's a monomial, and this is a two terms, like bicycle, meaning two wheels. This is going to be a binomial. Notice they all have the same suffix, nomial, like this. Okay, so we're going to talk more about the degrees a little bit later. I want to get through all the classifications before we do any more of that. So let's go on to the next guy and show you what three terms strung together in a polynomial that's more complicated would look like. So let's say you have a polynomial, x squared plus 2x minus 3. That is three terms linked together. Notice it follows the definition. I said a polynomial was multiple terms, that's a term, that's a term, that's a term, linked by either plus or minus signs, that's true, with different powers of x. So here's the power of x to the power of 2, x to the power of 1. This is a constant, really. If you think about it, there's an invisible x to the power of 0, because anything raised to 0 is just 1. So there's really an invisible x to 0. Anyway, it doesn't matter. It's a constant term, so you have three terms linked by plus or minus signs. Another polynomial like this would be with three terms, x to the power of 3 plus 2x squared plus x. That's three terms linked with plus or minus signs. Another one would be negative x to the fourth power plus x minus 5. Now, we like to give special names in algebra when we can, right? So these are polynomials with one term. These are polynomials with two terms. So when we have polynomials with three terms, we have another name for that. What do you think it's going to be called? Trinomial, like tricycle. Trinomial. So one term, two terms, three terms. But what is exactly in the terms? It just means different powers of x linked together with plus or minus signs. Three terms, two terms, one term. All right? So that's all the special names that we really have, because we have special name when we have one term, special name when we have two terms for a polynomial, special name when we have three terms for a polynomial. Once we get past three terms, we don't really have special names anymore. We just call it polynomial. So a generic polynomial with lots and lots of terms might look like this. 5 times x to the 5 plus 3 times x to the 3 plus 2 times x to the power of 2 minus x plus 4. So how many terms do we have? 1, 2, 3, 4, 5. So we have more than three terms. We don't have special names anymore. We just call it a polynomial because poly means more than one. What if we have another polynomial, 4 times x to the 6th power minus 2 times x to the 2nd power plus 3 times x minus 2. 1, 2, 3, 4 terms. So you might actually have on an exam, here's a polynomial. How many terms do you have? 1, 2, 3, 4. There's 4 terms. 1, 2, 3, 4, 5. 5 terms. But in any case, because it's more than 3, we just really call these polynomials. So in your book or on an exam, in general, the general class of all of these things is called polynomials. When we have one term, you can still call it a polynomial, but because it only has one term, we generally refer to it as a monomial. You can still call this a polynomial, but because it has two terms, we really call it a binomial. Same thing with this, we generally call it a trinomial. Anytime more than that, we call it a polynomial. All right? So now what I want to do is get a little bit of practice with polynomials. We talked a little bit about, in the beginning, we talked a little bit about the degree of these terms. The degree of this was 2, degree of this was 4, degree of this was 5. The degree of a term of any kind in a polynomial is just the highest power of that term. So what we want to do for the next kind of set of little examples that we have here is I'm going to write down a polynomial, and you're going to have to do a couple of things. The first thing we're going to do is simplify the polynomial. You'll see what I mean by that when we get there. We're going to simplify it as much as we can, which means we're going to add like terms together. Then once we do that, we're going to write the polynomial in descending powers of x. When you write these polynomials, notice how I wrote it. X to the 5, x to the 3rd, x to the 2nd, x to the 1st, and then just a constant. So usually when you write polynomials down, you write them with the biggest power first and you go downhill from there. So we're going to simplify them. We're going to write them from biggest power to smallest power. And then we're going to state the degree of the polynomial. So in the previous part, I showed you how to define the degree of the term, of an individual term. Now I'm going to show you how to find the degree of the entire polynomial. So polynomials generally have a degree associated with them. It's very easy to figure out, but it's easier to show you by an example. So let's take a look at our first problem. Let's say we have, as a polynomial, 2 minus x squared plus 3 times x plus 2 times x squared minus 5x. So a couple things we need to do. First, we need to simplify it. Then we're going to write it in the correct sequence of decreasing powers of x. Then we're going to figure out what the degree of this polynomial is. So when you simplify any polynomial, the first thing you need to do, the only thing you really need to do, is you have to add like terms. Now I'm going to tell you right now one of the most important things that will save you in algebra. When you're adding like terms, what it means is the variables that you add together, in order to add them, they have to have the same variable name, and in order to add them, they have to have the same exponents as well. So the only way you can add things together in algebra is if everything matches except for the number out in front. Then you just add the numbers and you carry along the variable and the exponent with it. But if they have different exponents or if they have different variables, you can't add them. It's like adding peanut butter to jelly. I mean, sure, I can put them both in the refrigerator and they're both jars. But besides that, peanut butter is different than jelly. You can't add them together. I mean, we all make sandwiches. I'm talking about adding them as an item, right? In algebra, the only way you can add them is if you're adding peanut butter to peanut butter. And the only way you can do that is if the variables are the same and the exponents are identical. That's the only way that you can add them together, because that means they match. And that when they match, you can add them, just like adding anything together. So when we look at this, we start scanning, we start figuring out what can we add together. So I see I have an x squared term here. I'm going to put a little dot under it for right now. And I start looking, do I have any other x squares? I have an x squared term here. I can add these terms together only because the x is the same variable and the exponent is the same exponent, right? I cannot add these terms together, for instance, because even though x is the same, the exponents are different, so I cannot add them. This is peanut butter, this is jelly, right? I can't add the 2 to it because 2 is completely different. There's no x at all, right? So I can only add peanut butter to peanut butter, for lack of a better word. X squares to x squares. That's the only way things match. So what I'm going to do, before I actually add it, is I'm going to rearrange the whole thing. I'm not going to add anything yet. I'm just going to put the terms next to each other to make it easier for you to see. So we have the negative x squared here. I'm going to write this term right next to it, 2x squared. Then I have the 3x. Then I have the negative 5x. I have done no addition. All I've done is rearrange the terms for the addition to put the x squared terms next to one another, because then it becomes very easy for you to see that I can add them. Now, once you know you can add them, you look at the coefficient. This is a negative 1. This is a positive 2. What is a negative 1 plus a positive 2? We've done all that stuff in the past, so by now you should know negative 1 plus positive 2 is going to be, the 2 comes along for the ride, negative 1 plus positive 2 is plus a 1. X squared. So it's an invisible 1 out here. I've added the negative 1, the positive 2, I gets me a 1, but 1 what? 1 x squares. That's what I've added together. These are the peanut butter terms, so I have to carry it through because I have one of them left. Another way you can think of it as 2 minus the 1 from here gives you 1 x squared. Then I look over here and I see I have like terms again, only because the x is identical with the x and the power is the exact same as the power. Then I have to say, what is 3 minus 5? 3 minus 5 is negative 2. So I write the negative 2, but what have I added together? I've added x's together. So the x comes along. So this is how you add things together. I've taken it very, very slowly at first because it's so critical that you understand how to add like terms in algebra. We're going to do a lot of it, and we're not going to go quite so slow moving forward. But in the beginning here, I want to make sure you absolutely understand. Now, the next thing we want to do is once we've gotten it to a simplified form, we check and just make sure. Can we add these together? No, because there's x and x squared. I can't add that. And can I add any of these together? No. Even though x is the same, the powers are different. I can't add them. I can't add these. I can't add anything else. Even though I want desperately, of course, you know, I want desperately to be able to add it and make it simpler, but I just can't because they're all different. It's like adding spaceships plus, you know, snow cones. I can't really add them. I mean, they're things, but I can't really simplify it anymore. So I leave it like this, but I always want to, if I can, write the biggest power of x first, then the next power of x, don't forget the negative sign that comes along with this term, and then the constant last. This is how you would write the simplified form of this guy, x squared minus 2x plus 2. And you would circle that on your test. So if your teacher said, hey, here's an expression, simplify it and write it in, they might call it standard form, or might say write it in decreasing powers of x. You combine all the terms, then you rearrange everything so you have the biggest power of x first, then the next power of x, then the constant just goes at the end like this. All right, that was only part of the problem. I want to find what we call the degree of this polynomial. Right? So what you do to find the degree is you have to look at every term. first of all, you figure out what the degree of each of these terms are. Remember, we did that. I said the degree of this is just 2 because it's the power. The degree of this is 4 because that's the power. The degree of this is 5 because that's the power. So what we do is we find out the degree of everything, and then we just pick the biggest degree of all of them, and then that's the degree of the whole thing. So what is the degree of this? The degree of this is what? It's the power of 2, so it's a degree of 2. What's the degree of this term? Well, it's x, but it's to the power of 1, so the degree is power of 1. What is the degree of that one? Believe it or not, the degree of this is 0. How do you know? Because really there's an invisible x to the power of 0. When you studied exponents a long time ago, you might have learned that anything to the power of 0 is always 1. It's always defined to be 1. So even though it doesn't look like there's an x term here, there's really an invisible x to the 0. Why is it invisible? Because x to the 0 is 1, and 2 times 1 is 2, so you don't have to write it there. But that's why it's a degree of 0, because the invisible exponent there is actually 0. So the degree is 2, 1, 0. And so then to find the degree of the entire polynomial as a whole, you just pick the biggest one, and you say the polynomial degree is equal to 2, which is just the biggest one of this list. So when you have a polynomial, you just find the degrees of every term, and then you pick the biggest one, and that's a degree of the polynomial. All right, pretty simple. Now that we've done that one and we've taken our time with it, we can do the next one slightly faster. What if we have negative x squared plus 3x to the third power minus 3x plus x squared plus 2x? And we have to simplify it, write it in decreasing powers of x, and figure out the polynomial degree. So we start scanning for, we find our biggest power of x, which is this one, and we say, okay, we put a dot. I usually put a dot under it to show myself that I've actually looked at it. I'm looking for any other power of x to the third power. I don't see anything. So I'm going to go ahead and write this as my biggest power of x down here. Whoops, not x to the power of 2. It's x to the power of 3 right here. And then I start looking for x squares. I see that I have an x squared term right here, and I have an x squared term over here. I don't have any other x squares. I have a negative x squared and a positive x squared, which means negative 1 plus positive 1, which you all know is 0. So these terms, I'm going to put a little arrow here. These terms here, right, actually add up to 0. So the whole thing drops away because negative 1 plus positive 1 is 0. So I don't actually have to write it down at all in my answer. Then I go and look and say, well, here's a term in x to the power of 1. Here's a term in x to the power of 1. So what is negative 3 plus a positive 2? Negative 3 plus positive 2 is negative 1x. There's an invisible 1 here, so that's why I don't have to write the 1. When you put it as a coefficient, it's implied that there's a 1 there. So 3 minus 2 is 1, so 1x, but I don't have to write the 1. So this is actually the answer, simplified, and it's also written in decreasing powers of x. And then I have to ask myself, what is the degree of this guy? Well, the degree of this guy is 3. What is the degree of this guy? It's just x to the power of 1, so the degree is 1. So then I just take a look at both of these things, and I figure out what is the largest one. The polynomial degree is just the biggest number, which is 3. So the polynomial is degree 3. All right, so we add up the terms, we write in descending powers of x, we figure out the polynomial degree. Now I have 2 more problems, and they are significantly more difficult than the last 2 we've done at first glance. Actually, they're not really any more difficult at all, but they're going to look like they're monster problems. Just kind of take a breath with me and let's go through it. What if we have a polynomial that looks like this? X to the power of 2 times y to the power of 2 minus x squared plus 8x squared y squared plus 5x times y minus 2 times x squared. Now this one looks significantly more difficult than any of these for a couple reasons. There's a lot of terms, but notice that in this term I have x's and y's multiplied together. I have x's and y's multiplied together, x's and y's multiplied together. So at first glance you're like, oh my gosh, I have no idea how to do this. But what you need to do to simplify this is you just look for like terms. And what I told you before still applies. To add things together or subtract them, the variables have to be the same and the exponents have to match exactly. That's the only way that you can add them. If they're different at all in any way, you can't add them. So I look and say, all right, I put a dot under here. Look for any other terms that have x squared, y squared. That's not going to work. Now you might think that that has an x squared, so it matches, but it's different because there's no y squared. So I can't do anything, I can't add them, they're not identical. I get to here and I say, oh, here's an x squared and a y squared, so I can actually add them together. And so I'm going to do that. I have an implied 1 here plus 8, which means that I'm going to have 9 what? 9x squared y squareds. That's what I'm adding together, this and this. There's 9 of them now. See, there was 1 from here and 8 from here. There's 9 of those now. Then I start scanning and continuing on and saying, all right, here's an x squared term. Do I have any other x squared terms in here? That's not going to work because even though there's an x, it's a different power, plus there's a y here, which isn't even there at all. But this one matches because there's an x squared. So then I say -1 minus 2, or plus a -2, however you want to think about it. -1 plus a -2 is going to give you -3. So I write down -3. -3 what? I'm adding together x squares. So it's -3x squares. All right, like that. And then I say, okay, what else do I have left? This guy, I'll put a little dot under it. There's nothing else left in the problem. It's 5 times x times y, and I've already taken care of all the other terms. There are no other terms in here that is just an x times a y. I mean, you think that would work, but that has squares. That's not identical to this. That's not going to work, that's not going to work. So what you have is just plus 5 times x times y. So you could write this down and circle it as the solution to the problem, and that would be correct. You've simplified the polynomial, and we've written it in decreasing powers of x. Here's an x squared. Here's an x squared. You kind of have to choose between the two, but we'll put that one second. Here's an x to the first power, so he goes last. And then the next thing you want to do is, what is the degree? Now, here's the part I didn't tell you. To find the degree of this term, you have 2 exponents with different variables. To find the degree of this term, you just add them up. 2 plus 2 is 4. So you just add all the exponents together. To find the degree of this term, you add all the exponents together, but there's only 1, so the degree of this guy is 2. And you add the exponents together here as well, which is what? Here's an exponent of 1 and 1, so you add 1 plus 1 is 2. So when you have different variables in your terms, to find the degree, you just add the exponents together. So degree 4, degree 2, and then once you write them all down, then to get the answer for the degree of the entire polynomial, you just pick the biggest one, polynomial degree 4. And that's the answer, polynomial degree 4. So, all right, now for our last problem, it's going to look even uglier than that. It's going to look like this, 4x squared y times z to the third. So now I have 3 variables with different exponents, all in that first term. Minus x times y times z, that's 3 guys multiplied together, plus 2 times x squared yz cubed, plus 5 times x cubed y squared z squared. Let me just double check I wrote it down. 4x squared yz cubed minus xyz, 2x squared yz cubed, 5x cubed y squared z squared. Okay, so it looks really ugly, but basically it's the exact same principle. In order to add these, you have to have identical variables with identical exponents. That's the only way you can add anything together. So I take a look and put a dot in this first one, and I say, do I have any other terms here that have an x squared, a y to the 1 power, and a z cubed? That doesn't match. Here's x squared y to the 1, z to the third. That one matches. This one down here is different. There's different exponents, so that one doesn't work. 4 plus 2 is what? Is 6. And 6 what? It's 6x squared y times z cubed. That's what I'm adding together. That 2 kind of looks like a 1. So let me erase that. I'm going to make sure it's clearly a 2, like this. So you just add the coefficients together, and then you've taken care of adding those things together. Then I look and say, here's my next term. Do I have any other thing like it? These are completely different. So even though I would love to add them, they're different. I have an x, y, and z and an x, y, and z, but these exponents are all different, so I can't actually add them. So what do? You just carry it along. You still have the x, y, z, and you still have the 5x cubed y squared z squared. You can't add them even though you'd like to. Now this is what the polynomial looks like simplified. Although, I guess I should say, it's not in decreasing power of x. I told you I wanted to write it in decreasing power of x. Notice here's an x squared, here's an x to the first, here's an x cubed. So if I really wanted to write it in decreasing power of x, this term would come first. 5x cubed y squared z squared. Then this one would come next, plus 6x squared y times z cubed. And then this one would come third, minus x times y times z. So this is actually, they're the same exact thing. It's just typically when you write them, you do it in decreasing powers of x, like this. Let me just double check. 5x cubed, y squared, z squared, 6x squared, yz cubed, and xyz. Then I want to figure out what the degree of this polynomial is. Now, to find the degree of this term, I just add the exponents together. 3 plus 2 is 5, plus 2 is 7. And the degree of this guy, add them together. 2, 3, 4, 5, 6. And then I add these together, 1, 2, 3. So, to figure out what the polynomial degree is, I just pick the biggest of each of the terms. The largest degree is 7, so the polynomial degree is 7. So I have 7, 6, 3, and 7 is the biggest. So even though this problem looks crazy, I mean, I admit it looks crazy, it's the same exact process. In order to simplify any polynomial by simplifying it, you pretty much want to add or subtract like terms. You can only do that if all of the variables and all of the exponents match. If you have any difference at all, then you just can't add them, even though you want to. And you just have to keep them along as strung along with pluses and minuses in the polynomial. Then to figure out what the degree is, you just find the degree of every term and then pick the biggest one. And we've done that here. So make sure you can do all of these and then follow me on to the next lesson. Even though we have started to do adding terms and polynomials, we're actually going to spend a couple of sections simplifying polynomials by addition, adding polynomials together. And then we'll talk about multiplying polynomials, which is the next most important thing. You might think that polynomials are pretty important since we're spending so much time, and you would be right. Polynomials is one of the most common mathematical functions you will find in all of math. And that's why we're going to spend so much time. So follow me on to the next lesson. We will learn how to add polynomials in algebra. Learn anything at mathandscience.com.